Hello, Assalamualaikum. We are from Group 13. Today we will present the assignment STEAM kit. The STEAM kit we made and choose is the DIY hydraulic mechanical claw. So, these are the members of Group 13. The first group member is Daniel Irshad bin Muhammad Yazid. His matric number is B1424-10019. And the second group member is myself, Nur Fatih Shazwani binti Ahmad Hairul. My matric number is B1424-10472. So, introduction, the device is a hydraulic claw STEM kit used to demonstrate basic fluid mechanics. Works based on Pascal law. Pressure is transmitted equally in a closed system. Use control and actuator screens connected by a tube. Pushing the control strings move fluid to the actuator. Fluid motion is converted into movement to open and close the claw. Helps understand basic hydraulic systems used in industry.
To develop the formula for hydraulic system, we start by calculating hydraulic pressure, using which define pressure as force divided by area. Then we establish the relationship between input and output force with where and represent the areas of the input and output piston respectively. Next, we compute piston areas using and apply the principle of volume conservation, expressed as ensuring that displacement and area are balanced. Finally, we determine the maximum load through a load test by adding weight until the claw can no longer lift, using the formula to calculate weight based on mass and gravitational acceleration. To calculate the piston area, we use the formula where the input piston with a diameter of 1.7 cm give an area of approximately, and the output piston with a diameter of 1.1 cm give an area of output. From this value, the mechanical advantage of the hydraulic system is determined using which equally. And finally, the output force is calculated using with an input force of 10 Newton. The output force becomes demonstrating how the system applies fly force based on piston size differences. Using the given data where the input force, input piston area, output piston area and output force, the pressure in the hydraulic system is calculated by applying the formula, which for the input piston give, and for verification using the output piston give, resulting in a final pressure of approximately, confirming that the pressure remains consistent throughout the system as per Pascal principle.
Involvement of mechanism, interpretation of result, and new understanding. The involvement of mechanism is the hydraulic claw operates based on Pascal's principle. Force applied to the input piston creates pressure in the fluid. This pressure is transmitted equally through the hydraulic tubing. Next, the pressure causes the output piston to move and operate the claw, and different piston size affect force and displacement.
From the interpretation of result, the mechanical advantage obtained was 0.42, indicating that the system does not amplify force but instead allow the output piston to move faster and over a greater distance. As a result, the output force was smaller than the input force, while the calculated pressure remained approximately and constant throughout the hydraulic system, which confirms Pascal principle and demonstrates how pressure is transmitted equally in all directions within the fluid.
for new understanding is first, hydraulic system can trade force for movement. Second, smaller piston produce less force but greater displacement. And next, pressure in a closed hydraulic system remains constant. Piston size plays a key role in system performance. And last, hydraulic mechanisms allow precise control of motion.